1 minute to go. So if anyone wants to find out about renewable growing media.
Yes, yes. Oh, yes, please.
Hi, welcome.
No, this is very efficient. It's very Dutch.
Yeah, that's true. Event organization is a huge specialty. I was visiting Italy and thinking, man, they need Dutch speaking directors. It's just like, here's a statue. There's no plaques, there's no information.
Okay, it is 10:45, so we're going to get started. Good morning, everyone, and welcome to this panel discussion on renewable growing media and how to grow crops and how that affects everything in the industry. I'm joined today by Martina Holtkamp, Ned Busic, and Joseph Stoner. And today we're going to see some presentations, and that's then going to be followed by a panel discussion where we can really get into the details. And please think of questions yourself, because we'll be, of course, accepting questions from you as the audience. I'd just like to ask the panel members, would you like to briefly introduce yourselves before starting presentations? Perhaps, can we start with you, Martina?
Good morning, everyone. My name is Martina Holtkamp, Managing Director of RHP, Knowledge Center for Substrates.
Thanks.
Morning from my side. My name is Ned Busic. 7 years in substrate industry, 8 years as a head grower, and working in Kekkilä-BVB, substrate producer.
Thanks.
Yeah, hello, my name is Joseph Stoner with Wageningen Research in the root zone dynamics group, and I mostly research substrates and plant nutrition and water dynamics in substrates and in the soil.
Wonderful. So as you can see, we've got quite a nice overview. We've got certification, manufacturing, and research, and hopefully we can get some nice insights from the discussion today. But first, we're going to start with presentations, and to give us an overview of what's happening in the world of knowledge and certification, I'd like to invite Martina to present what you've been working on.
Thank you, Alexander. Today we're talking about new growing media. My presentation will focus on the consequences of the new growing media. But before I start with that, I would like to give a brief introduction about RHP. Like I say, we are a knowledge center for substrates. And with our team of 18 people, we basically work on 3 different activities. First of all, research. Meant to develop new knowledge related to substrates and substrate raw materials. Also, we perform routine analysis in our own greenhouse and laboratory. Next to that, we have a team of technical advisors visiting the RHP certified companies, providing them with their knowledge and experience to optimize their processes. And in the end, last but not least, we have our quality marks, the RHP quality mark and the RHE quality mark, which guarantee the safety and quality of substrates for both the professional and horticulture industry, but also landscaping products. New growing media is our topic for today. I would like to start with a small overview on what we are talking about. And, some of them are appearing on the screen. There was a study conducted by the Wageningen University. It was published, I think, last year, 2 years ago, which gives a large overview of raw materials which have the potential to be used in substrates. Some of them are mentioned in this slide. We can think of materials from landscape management, forestry management, coir products, composts, but also grasses and reeds. So there's a wide variety of materials that could potentially be used in substrates. However, they are not all as suitable as we would like to. And we also see a difference between waste streams, for example, the coir products that we use, the bark that we use, but we also have a specific production, which is, for example, miscanthus, a new product coming up. Not all these materials are as suitable as we would like. And to explain that in a little bit more detail, I like to use this overview. It's a very simplified drawing of the process, how we come from a raw material to finally the plant that we would like to grow. And if we start with the raw materials, when we talk about renewable materials, we can identify some safety risks. These risks can include, for example, the presence of human pathogens, heavy metals, but also residues of pesticides, plant toxic substances. So we need to identify what these risks are and how we can minimize them later on in the process. In order to minimize them, we need to process the raw materials. There are different techniques already available, but when we start using new materials, we also need to develop new techniques, for example, for the hygienization and the stabilization of the materials. And even with these processes techniques, we need to conclude that several of the raw materials which were mentioned in the slide before will remain unsuitable for the use in a substrate. Well, the materials which are suitable, and we are happy to conclude that there are quite some, they will be used in a substrate. So based on a recipe, a substrate mixture is created. Also there, and this is mainly for the grower who starts using the substrate, need to be aware that a substrate based on renewable materials will have different characteristics than he is used to with the more traditional materials. So you can think of nitrogen immobilization, but also a lower pH buffer. The water uptake of the material can be different. The nutritional imbalance. So these are all aspects that we need to take into account. It doesn't mean that the product is not suitable, but we need to take it into account, and the grower needs how to learn how to deal with these new materials to optimize his growth. This whole process is not something that we can do by ourselves. As a knowledge center, we provide the industry with knowledge on the new materials. But the main message is that to conclude this whole process, we need to cooperate. Producers need to work with the growers. So we need to find each other there, and we also need to realize that we shouldn't only focus on the sustainability aspects of the substrate itself to lower the environmental impacts, because this can lead to eventually a higher impact further in the chain. And therefore, we need a more integrated approach where we not only look at the substrate, but also how it's being used. But I think the main takeaway here is that this is a process that we need to do all together.
Thanks, Martina. Thanks. Great overview, and as you can see, I've heard that the transition to renewable growing media is really a bit like when growers in the Netherlands switch from soil to substrates like stone wool, and a lot of knowledge, a lot of back and forth between everyone in the chain, so something we can discuss later. Ned, would you like to...
Yeah, thanks. It's a great intro from Martina, and I think it fits well now what the industry or substrate manufacturer has to also present. We are definitely seeing a change in the recent years, and definitely I agree with the term of new growing media or new generation growing media, because we are entering the new world, and definitely what we also see that what you also saw, the raw materials that Martina showed, we are of course using them, developing also the new ones, and we are searching for more. For substrate industry, it's really important the scale of the raw material as well. Of course, all the technical properties, safety, but also scalability, because we are as we are entering a new chapter in the substrate world. we actually have to see the traditional raw materials are actually big in volume. So we have to replace actually and grow more with the new raw materials. So the scalability is a crucial thing. But we also see that the whole industry is actually developing. So it's not just substrates, it's also the whole greenhouse technologies. It's advancing, and we have to keep up, and also we have to provide solutions for the whole industry. So definitely the substrate in future and in the presence as well needs to be really uniform, because the more and more greenhouse technologies are automized. You see in the green tech now that a lot of robots, a lot of engineering things in the greenhouse, and definitely substrate needs to fit well in that system. Cleanliness, safe, and also consistency, so that the properties of the substrates are the same throughout the year, and also that it performs all the time the same. Because if you have a chain, if you have, let's say, a lettuce grower, you are seeding, germinating, you cannot fail in any of those steps. So the substrate is an integral part of the whole process. And definitely, you are targeting a specific performance for the specific technology. Substrate is not one size fits all anymore. You need to really target the specific performance. And that's why we are also seeing opportunity in the new materials that are more engineered, that they are actually industrially produced. They are not dependent on the weather conditions like before. They can be produced on demand, and it's actually much more flexible also for the industry itself. And definitely, when we are innovating and checking the new raw materials in the industry together with the partners like Wageningen University or RHP, but also our internal research, it's really important to align well with the business strategy. And when I say business strategy, it's more how you approach the growers. Of course, we as an industry, we also need to be really close to our customers, and that's the key. If we just produce our substrates, ship it around the world, for example, our company is shipping more than 100 countries in the world, and it's really difficult actually for everybody to reach every grower that you are supplying your substrate for. But you need to be close to them, have the local partners to explain to the market and also to the growers changes that are coming and that are maybe already there. If you are just producing substrate, a new raw material, ship it, and then you think your job is done, it's actually just the beginning. So you actually after-sale support, and of course the more important is the pre-sale support, that you are actually preparing the growers for the change. And I think that's at least our business model and the strategy, that we advise the growers beforehand, start with the baby steps, and also go into the change and give them some time. So it cannot be a change of let's say half a season or a few months. It needs to be a few years, so that everybody in the chain actually aligns and tests the substrate well. One of the examples here, for example, I want to show, this is not a game of, let's say, that these spot the difference between the photos. There is a difference, of course. So you can see the traditional mix with only one raw material inside. In the middle, it's a mix with two raw materials, and then the mix with three raw materials inside. And this is just a small example how the new technology, maybe you recognize the sleeve system here. So the new technology is actually able to utilize the new substrate. So here we have maybe totally different kind of performance in these three mixtures, but the technology is able to cope with it. And this trial actually showed us that, of course, we worked with the grower how to adjust the irrigation strategy, how to adjust the fertilization, but definitely the new technologies are also pretty crucial, how to use the new substrates, which are, let's say, containing different kind of materials than before. Another innovative solution, which is maybe not so new, maybe you saw grow bags, let's say 20 years ago, but what's innovative about them is that we are, of course, now using more new raw materials inside them. The grow bag itself, of course, you in the Netherlands you see big piles of let's say inert raw materials that are traditional for vegetable hydroponic production, and this is a good solution for that, and actually a second life of this kind of substrate solution for vegetable production is a key, and it's also a pretty big opportunity also for the growers. The tests show that actually with these kind of products you can actually push the yield even higher. So of course every year you read maybe a Horti Daily or other media that okay, this is the record yield in cucumber, in tomato. Actually what we believe in these kind of products you can actually push that record even higher. Why?
Wow.
Because it's also not one size fits all. In the grow bag you can actually tailor the mix based on the performance. We as a global company, of course, we are not only present in the Netherlands, we are selling to different countries, and technologies in those countries are maybe not the same as in the Netherlands. Maybe the technology is lower, so definitely not all the climate conditions in the greenhouse can be adjusted. So this is a nice example how the innovation can help with few of the problems that this industry has. And just another example here, or what we are facing now, and also from RHP Research and Wageningen, we are of course collaborating in the microbial activity of the new materials. This is a really big change comparing to the traditional materials, where, as said, new materials are industrially produced, often sterilized, often produced in a high temperature, and the microbial activity in them is really low. Of course, it means it's good, clean and safe, but it's also meaning that it's not good because it's maybe too clean. And that's also a warning, because when it's too clean, it means that actually pathogens can also come in. So we are actually really deeply now researching together with the partners. We are having different kind of solutions now to actually enrich the root zone environment with the new raw materials. But we are also seeing an opportunity here, because actually a lot of new materials are giving a lot of air into substrates, and actually that kind of environment is good for enriching and actually having better microbial activity in the substrate and the root zone. Yeah, that's from me.
Great, thanks Ned. Yeah, really nice to see the things that you're considering from the perspective of manufacturing and contact with growers, so I hope we can come back to that. But now I'd like to introduce my colleague Joseph Stoner, who's going to talk about biochar, so the floor is yours.
Yeah, thank you. So we discussed first with Martina the overall industry and the challenges with replacing existing materials with new materials, and then we dug a little deeper with specific substrate mixes with new materials with Kekkilä-BVB, and I wanted to dig in all the way to a specific material and some of the challenges that are present and opportunities with this material. So biochar in tomato cultivation is the topic. First off, what is biochar? Biochar is a type of charcoal, you can say, produced by applying heat to plant material at low or no oxygen levels. The temperature is typically between 500 and 1000 C, and the materials are processed in an efficient way, typically in a continuous process. They're carbon rich, mostly carbon actually. They're very porous, and sharing the quality with charcoal, they're also incredibly stable, so they do not degrade so much when you are cultivating on them or afterwards, for that matter. Typically at this point in time, they're produced as a byproduct of green energy production, and they're used most as a soil improver and then as a carbon storage medium, a carbon sequesterer in the soil, owing to the very high stability of the material. So why use it as a substrate? Well, it's an additional step of valorization between production and application to the soil. As Ned mentioned, they want their substrate bags to go into the soil afterwards, and this is a great material for that, because it really will hold the carbon within the soil for quite an extended period of time. It will also help close the loop, so you can replace raw material inputs with agricultural waste, and it has the potential for improving the stability of organic substrate mixes. Since it doesn't degrade, it can help hold up the structure of a mixture as the substrate other components begin to degrade. And it also has potential, as seen in soil application, for disease suppression. There's some research on the addition of a small amount of biochar into substrate mixes to help with the fusarium and other diseases in bell peppers, chrysanthemum, and some other crops. So how does it perform? Well, we did a trial with 100% pistachio shell biochar and compared it to coconut coir in a 6-month tomato cultivation in 2024. And I wanted to discuss a little bit about some of the specific aspects of the material that are different than coir and that had to be managed, specifically the pH and the irrigation. So for pH, you can see in this chart a pretty simple story that biochar starts with a very high pH, and it takes quite some time to work through the pH buffer to get it down to a typical cultivation pH that you're expecting. For a tomato, you're wanting to be between 6 and 5.5. The way that we managed specifically the control of the pH in the cultivation was to increase the ammonium concentration. This helps to acidify the area directly around the roots and gives the plant a bit of protection from the overall pH of the material. So in that way, we were able to have a successful growth despite the long climb downwards to the pH that you're interested in. But on the flip side, when the pH buffer is empty, you must quickly remove the extra ammonium from the recipe to prevent an over-acidification of the material. So this is quite a complicated graph, but bear with me. First, we're going to look at the top portion of the graph. Orange is coir, and green is biochar. And the simple takeaway here across the cultivation is that the water holding capacity of biochar is much lower than coir, which already has a somewhat lower capacity than some other materials. So the water holding is lower. You don't have such a water holding buffer, but what this also means is that it's very, very difficult to over-irrigate biochar. It will not flood the substrate, and you will not have flooded roots. As you see here on the second and lower graph, the blue line is the irrigation schedule over the course of a few days. And again, green is biochar and orange is coir. And you see that on the left side, throughout the day, the biochar resists increasing the water content too much despite the same irrigation schedule as coir, which continuously increases until the end of irrigation, although much more slowly by the end. And then interestingly, on the right side, you see that at the end of the irrigation for the day, the green line, the biochar, does not decrease nearly as much and does so much quicker, meaning that it reaches its sort of drain out water content much quicker and holds more water throughout the night, meaning that you have actually a larger buffer at the instant you begin transpiring again in the morning when the sun comes out. So the results of the trial, as you saw from the pH graph, that is not necessarily the only challenge. So there were initial difficulties that reduced yield in the beginning, but by the end of the trial, the week-to-week production reached the coir substrate level, and there were multiple biochar treatments to address the pH at the beginning, and all of those treatments were within 80% of the harvest week to week, with an N of some 24 plants. So yeah, pretty statistically insignificant difference. And the biochar treatments that had more rinsing prior to cultivation did perform better. So that indicates that a clear step needed, much like coir prior to going into a substrate, is a soaking and rinsing step.
Yeah.
So biochar as a 100% growing medium does prevent challenges, although adequate substrate rinsing and pH control can help bring those challenges under control. And the water holding properties within a mixture can be improved with biochar in that it holds the water that it has very well and can help prevent drain out in a mixture, allowing for a higher water buffer at the start of the day. But the cost and supply are still limiting factors for the addition of biochar in substrate mixes commercially.
Great. Thanks, Joseph. So there we have it. We've had Martina from RHP giving us an overview of the challenges, then Ned from Kekkilä-BVB telling us a bit about the manufacturer's perspective, and finally Joseph on the specific material on biochar. And now we're in the panel discussion part of this session. So are there any questions from the audience? Just put your hand up and then they'll come and bring a microphone, I think. Does anyone have questions for any of our speakers? If not, I will, while you think of questions... Was there one? Oh, sorry. Thanks, Joseph. Yeah, there's one gentleman over there.
From your point of view, what's the application or practical application of the biochar?
What's the practical application of biochar?
If you have so much trouble bringing the pH to grower acceptable levels.
Yeah.
Yeah, thank you for the question. As I mentioned at the last slide, 100% biochar does provide a lot of challenges, but all of those challenges that are present in a complete biochar mixture are very much lessened in a substrate mix or in a substrate mixture of multiple sources. So it won't have the same pH contribution and can be managed to standard acceptable levels of other organic substrates when provided in the right mixture. So I would say, yeah, less than 1/3 would be a sort of eyeball number to prevent these problems from taking over the characteristics of the overall substrate.
Is this something you... sorry, my mic... Oh yeah, we got 3 microphones. Anyway, is this something you can recognize as well, Ned? What's your outlook for biochar?
Yeah, I would say maybe looking a little bit broader from the broader perspective. I think in the future, at least me as a technical manager in a substrate manufacturer, I would never recommend any of the new raw materials to be used 100%. Not that it cannot be done, but I think we are then losing the opportunity to actually make a tailored mix of different kind of materials, new materials, and using the advantages they have against the traditional raw materials. Biochar itself, of course, it can bring some benefits in a certain level. So, for example, some other raw materials like grasses or composts or different kind of materials, wood fiber, they are also having the limit where they are actually giving a lot of benefits, and then when you reach or go over that point, they are actually bringing or putting the mix out of balance. And that's something that is actually then tricky, and then what Martina was saying, that's no longer sustainable. You are having too drainy mix, then you are basically losing too much nutrients, water usage, and things like that. So it's responsible usage of the raw materials is important. So in that sense, biochar we also see as a potential material for future, but it needs to be used responsibly as well, and in the amounts that make sense in the blend.
Yeah, so as I understand it, you've got every mix will be tailored to the crop, and it will have multiple materials, each playing a role, and then in synergy provide the properties you need, right?
Yeah, exactly.
Do I see a question from Richard? Yes, the microphone's on its way. Do you have anything to add to that in the meantime, Martina?
Well, perhaps more specific on the certification. We haven't set any standards yet for biochar, but we see that this is a product coming up in the market, and if the interest is increasing, then we have started the first research studies already. If the interest is increasing, then we would be happy to develop the standards for it,
right.
To also bring the biochar under the RHP certification.
So there are still some things you need to see before you would...
Yes.
Yeah.
Yes.
Okay, makes sense. Well, more research to be done. Richard, you had a question.
Yeah, I had 2 questions. First one for Martina. How does RHP support substrate companies with their innovation and development? And the second question is there a biochar, or are there a wide range of different types of biochar?
Do you want to start?
Shall I start?
Sure.
Yes. The first question, how we support this kind of innovation. Within the RHP standards, we are quite strict. We have certain materials that can be certified. If a company like Kekkilä-BVB uses non-certified products, then basically we say it's not allowed to have them at your organization. However, we see that development is necessary, innovation is necessary. So we have our innovation support program, where we enable producers like Kekkilä-BVB to test, to start trials with new materials, and yeah, under circumstances, they are allowed to have it at their premises and to run some tests with it.
So it's really not a one-size-fits-all, but there is always potential for further development.
Yes, there's potential, and we have a clear follow-up system on what are the results of the first studies, what are the risks, how can we reduce the risks, and well, if we all feel comfortable with that, we can take the next step.
Yeah, because we really are in a transition, of course, so it's a lot of exploring, I can imagine.
Yeah, and we need to support the transition instead of blocking it by saying it cannot be RHP certified, so you're not allowed to use it.
No, exactly. Before we move on to Joseph about biochar, do you have anything to add to that, Ned, about the development of new materials and certification? How do you experience that?
No, it's a crucial thing, and I agree with that. Of course, RHPs is a big help for the industry as well, because of course we want to share the knowledge, and we also need to receive the knowledge from the RHP and other institutions. And for us, it's important to understand the risks. Of course, we have to figure out the opportunities on the market for that, and also hear the market, but also share the knowledge towards the growers and recognize the opportunities with the new raw materials, because we are truly believing that I think with the new raw materials there's a big opportunity for the growers to make a next step, to push the crop even further, have better yield, more healthier plants.
Wow,
and definitely with the new raw materials we can see that, but we are in the early stages still, I would say. With some of them we are further ahead, but I think overall for the new materials we are, let's say, slightly further from the beginning, but still there.
So there really is potential, because I often hear about it like, something that we have to do and there will always be trade-offs, but you see at the end of that tunnel that things might actually be better also from a yield perspective than before. That's really encouraging. Anyway, speaking of tunnels, not to go down a rabbit hole, we still had a question about different types of biochar.
Yes, thank you. So the question was, is there one biochar, or are there many kinds of biochar? And I think certainly the answer is that there are many kinds of biochar. The temperature that you process the initial feedstock with makes a very large difference in the properties at the end of the process. So not only the properties at the end of the process, but also the amount of energy that is produced will be different. So it's always a balance of making a profitable system where biochar is one of the end products of that system. So that's one issue, is the temperature and processing technology, and the other is the feedstock. So the common feedstock for biochar is wood. Typically as organic matter, wood waste from other industries that is already being burned for energy, for green energy within Europe. And when you optimize for energy production, you actually end up typically going to higher temperatures and making a more difficult product for substrate use. But the purpose, going back to the earlier question, of growing in 100% biochar was to show that it's possible, to show that with enough careful consideration and modification you can still succeed and have a good crop, with the end goal being that different kinds of biochar can find a place within substrate mixtures. Does anybody else have something to add?
No? Okay. Any other questions from the audience? So we've talked... Yes. The microphone is on its way.
Thank you. We are looking with all of us to new raw materials, and we know also why we do this. We like to reduce maybe the peat, sphagnum peat, but other things that we see in alternative raw materials is, for example, higher, with a scan of residues, we see things we see CO2 footprint as one important thing.
Yeah.
I think we speak about CO2 footprint for the raw material, but
Yeah.
how far must we go for the CO2 footprint, for example, and also for the residues in the end products?
Yeah.
Because we can find a lot of raw materials, and it's very difficult to find enough raw materials, scalable raw materials. But what about other important factors? Risk, residues, CO2 footprint. At the end, we have find a new raw material, but then the public opinion is coming, oh, I see this or I see that. So I think there are some very important characteristics, and I think these that the public opinion is facing now and looking to it, I think we need to take them quite early in the research with us. But I like to hear from the panel, what do they think about some critical points that we have now already in the picture?
Yeah, yeah. Would you like to
And why that we reduce the peat?
Sorry, say it again.
And why we reduced or like to reduce the peat, sphagnum peat.
Yes.
So that characteristics, yes. What do the panel think about that?
Yeah, because we're moving away from non-renewable materials like peat, but then where are we moving towards, and where do you draw the line in some of these things like contaminants and
especially
public
at the
opinion?
end of the culture and the yield, okay, I hear it's increasing for some raw materials maybe, but what about the residues and other things?
Yeah, yeah. Martina, would you like to start?
Of course. This is exactly the challenge that we're facing, Mark. You're completely right. There's a lot of discussion going on these days about peat because of the CO2 emissions. In some countries, for example, the UK, they already say we don't want to have any substrate containing peat because of the impact. I think in some countries beyond Europe, there's not a discussion at all. They still use the peat, and the discussion on sustainability is less. So mainly it's focused in Europe. And yes, this is a major challenge that we are facing. In the Netherlands, we have signed a covenant on reducing the environmental impact of substrates. So there the focus is on having LCAs of the raw materials. But like I already said in my introduction, we should not only focus on minimizing or lowering the impact of the substrate itself, because it will have an impact further on in the chain. Another thing that you're mentioning is what if we move towards other raw materials, and well, they can have their critical points as well. We can take coir, for example. Coir is the number 2 constituent being used in substrates for the professional industry. But coir is being produced in countries like India, Sri Lanka. Social aspects play a role there. So we need to prevent that the discussion is moving from CO2 impact of peat towards the social impact of production of coir, for example. And in the industry, we are working on several initiatives to counter this. Within RHP, we're working on certification standards, also to cover the social aspects of the production of raw materials. And what I think is that a lot of research, a lot of studies are going on, not only within RHP, not only in Kekkilä-BVB, but all the substrate producers. The Wageningen University is involved. As an industry, we need to tell our story, and we need to tell what we are doing and why we are doing this. And that's the only way that we can hopefully affect the public opinion and prevent that the discussion is moving from CO2 impact of peat towards other reasons why we shouldn't use any other constituents. But yes, this is a major challenge.
Yeah, and I suppose as RHP, you're obviously looking a lot at the environmental impact, life cycle assessment you mentioned as well. but there are also the other aspects,
There's also
social
other
aspects that
Yes.
you mentioned. Yeah.
Yes, but the environmental aspects are the main focus
Yeah,
these days.
that's the main
Yes.
driver at the moment, I think. Yeah, I'm curious, Ned, from Kekkilä, whether to what extent you're confronted, because also I think perception was mentioned, maybe not just from the growers, but also from the public, if certain materials are being used potentially with contaminants. To what extent do you get confronted with that?
Yeah, I think we have definitely from our example, we have a something called Kekkilä-BVB Sustainability Compass, where what was Martina saying also, we look a little bit broader picture of all the raw materials, so individually. And of course, if you put, let's say, peat or other raw materials under the microscope and analyze all the impact that every single raw material has, they are different. So I think if peat is the bad guy, then we also need to check other raw materials, because they are also having some aspects that are good and not good.
Yeah.
So it's also a little bit about perspective, like that when the supplier is also located in certain countries or in Europe, and then shipping the product somewhere else across the world, it's changing the impact of that product.
Yeah.
It's not the same if you are located in the Netherlands and delivering 2 kilometers from your substrate factory.
Yes.
So that product, maybe the same product shipped to China, is totally different.
Yeah.
So we approach it a bit broadly, and we actually have something called Sustainability Compass, where we are mapping actually impact of every material on several different aspects. Regarding residues, we are, of course, we have also circular raw materials. So the materials that we are actually taking back from the growers, doing some changes to them, or let's say processing them to make them more safe. But we are never risking, let's say, sending a substrate to the grower which is containing any residues, or it's risky to the grower itself. That's, let's say, a no-go. So definitely all the new raw materials, they have to be first of all safe for the user.
Yeah, so that's really your priority. And I'm curious, when you talked about the environmental impact of specific components, do you also take that into account when designing mixtures? I mean, obviously it's got to work for the grower first, I imagine, but do you look at substituting? Is that something you do as well?
So in our team, basically, we are responsible also for recipe making, and what is interesting that we are actually now having requests to make a recipe based on the footprint, which is not always easy.
No.
But we are capable of doing that. But also, what we want to show to the grower that if he has a blend which is maybe using for 5 or 10 years, and he wants a new blend which maybe is different with the footprint, then we actually compare them to next to each other. And I think the whole market and also the growers are pressured by their customers to show this data.
Yeah,
and for us, we are definitely now, it's interesting. Of course, it's not easy to make a blend based on that, but we are seeing now more and more requests like that we are making a blend based on the impact.
Wow, yeah, that's interesting to hear. We've got 3 minutes left, so we've got time for one, maybe two more questions from the audience. Does anyone want to ask anything to our panel members? Otherwise, I have a question about the economic aspect, which I don't think we've discussed that much yet. I've heard that these new materials can be more expensive. Do you think that will be the case in the long term once this has become more established? Maybe first for you, Ned.
Yeah, definitely we see a difference in price levels, but also I would say that the important thing here to focus on is the changes and the opportunities you can get from the new raw material. Of course, we are not, let's say, we are discussing openly that these blends often, especially peat-free mixes, are really different in price comparing to traditional mixes with majority peat.
Yeah.
And that's something that the growers see, but we also try to discuss with them that they need to see the opportunity from this. Maybe push the crop a little bit higher, get a better yield from it, but it's a long process. So we definitely see that even though that in the start and the substrate part, I would say all the growers, maybe of course they want to cut costs, but for one pot or one plug,
Yeah.
the substrate cost is really a small impact in the total overall cost price of the plant.
Right.
But still, I understand that point of view, but I think we should all focus on the opportunities. And also the new blends, for the new blend you actually need to also have new technology or better technology to be able to cope with that new blend.
What kind of technologies are you thinking of?
It doesn't have to be necessarily really high-tech technology, but a capability to, let's say, give more frequency in irrigation, dose the fertilizer in a better way,
Right.
more precise, because most of the new raw materials, they require changes in the fertilization strategy.
Yeah.
And if you are having a simple system, it's not so easy to cope with that.
No.
So advancing with the technology also gives you a license to operate, basically, in the new substrate world.
Yeah.
So.
And then the raw materials will cost a bit more. There's going to be a bit of a technological investment, but at the end, you're also expecting higher yields. Do either of our other panel members have something to add to that? Do you recognize that?
I have a little something to add. I think
last 30
part of
seconds.
the cost, 30 seconds, here we go. Part of the cost of new substrates comes from the complication of the sourcing the substrates and finding the right quantities. And it's inherently a much more complicated supply chain to make a mixture of many organic substrates that are not always available, potentially just seasonally available.
No.
When you're looking at that versus a large coir supply or a large stone wool supply that's very easy to keep consistent.
Yep.
So I think that these substrates, there's room for improvement in efficiency in the supply chain, and that will bring the cost down as they take on more use.
Yeah, encouraging to hear. We are over time. Any final words from any of our panel members? Okay, well, if you'd like to speak with them, I'm sure they'll be around for a few minutes, but thanks for joining and enjoy the rest of Green Tech. And thanks to you all.
Thank you.